Hello everyone. Today topic is the frequency reuse in the subject of wireless communication and networks. Myself, a Karthik, Custom Professor, Department of Electronics and Communication Engineering, Institute of Aeronautical Engineering, Hyderabad. Okay, coming to today topic is a frequency reuse. Okay, what is a frequency reuse? Okay, for that we have the outcome. Okay, whenever we learn the frequency reuse concept, then we can go for the improve of the signal noise ratio and also cell coverage. In the previous class also we discussed about the what is a wireless communication, what is a wired communication, the difference between the wired and wireless communication in the seen in the previous class. But coming to here, we have to learn the what is a cell concept, what is a frequency reuse, what is a handoff. Okay, so all these three methods are improving the signal quality and also improve the coverage of the cellular. Okay, mainly here we discuss about the today class frequency reuse. In the name itself, what is the frequency reuse? We can reuse the frequency in the particular cell coverage area. Okay, before that we have to know the what is a cell. Okay, what is a cell, how the cell splitting, what is a micro cell. Okay, we have to learn those concepts, then we can understand the frequency reuse concept. Okay, we can go for the previous class. This is a generation of the wireless communication. In the previous session we discussed what are the generations we have, the first generation to fifth generation, what are the enhancements. Okay, when it is launched, which generation when it is launched, we discussed in the previous session. But and also we discussed the second generation technologies and also data rates. Okay, what are the different types of data rates, which data rate having the which technology in the previous session we discussed. And also we go for the third generation also we discussed. Okay, coming to third generation, we have the different data rates and also different technologies. Okay, and also like that we go for the fourth generation. In the fourth generation, we have the two technologies, that is a LTE and also WiMAX. Coming to LTE, that is a long-term evaluation. What is a WiMAX means? That is a worldwide interpolability for microwave. Okay, here you can see the difference. Okay, coming to data rate of the LTE, that having the 100 to 200 Mbps, but coming to WiMAX, okay, some of the mobiles are using the LTE technology, some of the mobile phones are using the WiMAX technology. Here we have the approximately 100 Mbps in the WiMAX technology. And also we seen in the last class, there is the evolution of fifth generation. What is the first generation? What is that? Analog communication, that is launched in the 1979. And also coming to second generation, that is launched in the 90s and 91 between, and there we are using the text message. But coming to 3G, third generation, that is in 1998 and also 1999, in between that is launched, there we are using the mobile and wireless internet connection. Coming to fourth generation, we are in now fourth generation and also fifth generation. What is the advantage for the fourth generation compared to the third generation? You are using the cloud and also IP and totally mobile broadband in the fourth generation. Coming to fifth generation, unlimited data capacity. Okay, these are the big evolution for the cellular mobile communication. And also we see what are the wireless systems in the wireless communication. Okay, we have in the wireless sensor network and also cellular network, the multiple input, multiple output, and also orthogonally frequency division multiplexing. These are the main wireless systems in the wireless communication. Okay, what is a wireless network? Okay, this is also we seen in the previous class, and after what are the advantages also we seen. Before that we have to see the what are the advantages. Okay, you can see these are the very important topic, that is the advantage of the wireless communication. Here we can see the cost effectiveness, flexibility, convenience, speed, and accessibility, constant connectivity. Okay, these are the advantages for the wireless communication. This is also we seen in the previous class. Okay, and also main thing here we can see the specification in between the wired communication and also wireless communication. What are the specification we have for the wired and wireless? The first specification is the speed of operation, and also second specification is the system bandwidth, and third specification is the cost. You can see the difference between the wired and wireless communication. Coming to installation and also mobility and transmission media, those are the specification in between the wired and wireless communication. Okay, this is also we see. Now coming to today class, in the today's session we discuss mainly about the focus on the frequency reuse. Cellular radio system rely on intelligent allocation of reuse of channels throughout a coverage region. Okay, for example, you can see this is a hexagonal shape. Okay, actually this is a cell. In the previous class also we discussed what is a cell, what are the different types of cells. Okay, that is a square, circle, triangular, equilateral. Those are the different types of cells. But nowadays we are using the this hexagonal shape. This is called cell, and also group of cell is called cluster. Okay, here we having the different cells in a one particular region. Okay, this is called group of cell. Here the cluster size is 3. Okay, this is a cluster size is 3. Whenever you need the improving of the capacity of the particular cell coverage area, then we go for the frequency reuse concept. We can go for the frequency reuse concept. For that we are dividing the cells. For that we are dividing the cells. That is a called cell splitting. That is called cell splitting. That is called cell splitting. Okay, whenever we need the frequency reuse concept, for that we have to subdivide the cells in the particular hexagonal shell. That is called cell splitting. Those small cells also called microcells. Okay, those cells are called microcells. Okay, each cellular base station is allocated a group of radio channels. Okay, actually this is a cell. Here I already allocated the one group of radio frequency that is be used with a small geographical area called cell. Okay, coming to base station, in adjacent cells are assigned channels. Groups contain completely different channels to neighboring cells. Okay, what is a neighboring cell? What is a adjacent cell? What is a co-channel? Then we can see that those are the very important topic in this frequency reuse concept. Okay, this is a cell. Okay, this is a cell. This one is the neighboring cell. Okay, this one is a neighboring cell. What is a co-channel? Here and here we can subdivide the subdividing the cells in the particular coverage area. That is called adjacent cell. Okay, that is called co-channel cell. This is called adjacent channel cell. Okay, whenever any noise will be occurred, any interference occur in the particular cell, we go for these adjacent channel interference and also co-channel interference. That is completely different. We can see in the further classes also. Okay, this is a neighboring cells and also called adjacent cells. Okay, these in the frequency concept. Next, move on to the some particular cellular base station. What is the frequency reuse for frequency planning? Okay, that we can see. This reference we taken from this author, that is Max 79. From that we taken the frequency planning. Okay, before any installation, any setup. Okay, before any installation, any setup, we can go for the planning. That is a frequency planning. Then we can move on to the frequency reuse. Here we are limiting the coverage area within the boundaries. Okay, within the boundaries means this is a one A base station. This one is another base station. This one is a boundary. Okay, whenever the group of cell channels are being used coverage in different cells, then it is separated from the one other by distance large enough. Keep interference levels with the tolerable limits. Then we can having some problem. Then we can design the process of selecting allocating channels groups for the particular cellular base station. Okay, within the system, within a system we are giving some cellular base station. That is called frequency reuse concept. Okay, and also we see in the small cells what are the large cell. Okay, the cellular concept system level idea calls replacing a single or high power transmitter. That is called large cell. Okay, that is called large cell. What is a small cell? Within a many low power transmitter is called small cell. Whatever having the large cell and whatever having the small cells, each providing coverage area to only small portion of the service area. Okay, whenever you can use the large cell or also small cell, but each cells are large cells or small cells providing the coverage area to the particular whatever we giving the required coverage area, there we can providing the service to the particular coverage area. And also it is offered capacity limited spectrum allocation without any major technological changes. Okay, then that is some system design fundamental of the cellular concept. This even is already we seen in the previous class also with the graphical picture. Here we can see these are the mobile stations. These are the mobile stations. This is a MSA, mobile switching center. This is a PT, public telephone and a network internet. This is a wired network. Okay, here whatever having the transmitting signal, we can give the instruction to the mobile switching center, then it is transferred to the particular telephone network. From that we can having the another mobile station, then we can take the our user requirement particular call information to the mobile station. Okay, this is a concept that also we see in the previous class. Okay, what are the major operators also we can see here in the what are the mobile technology in India, and also what are the frequency bands, what are the major operators. Okay, coming to GSM, CDMA, and those are in the second generation, and third generation also we're having the WCDMA, WiMAX. In the fourth generation, LTE, Vivo LTE. Okay, for that, what is the frequency bands? What are the operators in India? Okay, nowadays we are using the 4G, that is providing the operator is Airtel, Vodafone, and Jio. Okay, these are the major operators for the fourth generation. Coming to fifth generation, this is a frequency. Now they are using the Airtel, Jio, Vodafone Idea. Now it is launched. Okay, in India, that is the fifth generation. Okay, and also we can see the frequency assignments in the different countries. And coming to UK, they're having the 890 megahertz to 960 megahertz, and US having the 825 to 890. Coming to Japan, that is a 870 to 940. What is the India frequency, FM radio frequency, that are 88 to 108 megahertz. Okay, here these are the assignments for the frequency. Okay, it can, with the help of the low power transmitter system and also increasing the network capacity, and the main concept of frequency reuse, and also it build the robust scalable system. And whenever it is the assignment of the frequency, it architecture to deal with the different user at the different places. Okay, then we can see the partition of the region into smaller regions called cells. Okay, what is a cell? We know it. What is a group of cell? What is a micro cell? What is a splitting cell? This already we learned in the previous session. But here we can give the partitions in that frequency assignments. We give in the some partitions. Each cell gets at least one base station. Okay, for example, here this is a one cell, and also here we having the another cell. Here each cell having the one base station. Okay, here each cell having the one base station, at least one base station. Whenever we are using the frequency reuse concept, we can place the another base station with the same radio channel. Okay, that is the concept of the frequency reuse. Okay, whenever what will happen, for example, in this coverage area, we are having the more subscribers. Okay, but one radio channel is there, one base station is there. Then how we can improve the particular coverage area? Okay, for that we are using the frequency reuse concept. Okay, then we can go with the another base station with the same radio channel. Okay, we can use the same radio channel, then the improving the cell capacity of the particular coverage area. Okay, these are in the frequency assignment, and also we can go with the frequency reuse. Coming to this one is a cellular structure. Okay, these are the properties of the cellular structure. Coming to channel reuse concept, here we can go with the two assignments. One is a frequency assignment strategy, one more is the dynamic frequency assignment. In the name itself, okay, up to now we discussed the what is the frequency assignment, what are the properties, but here we can see the two different types of frequency assignment. One is a fixed frequency assignment, and second is a dynamic frequency assignment. Coming to first frequency assignment, fixed frequency assignment, in the name itself, we are unable to change the frequency in the particular assignment. Coming to dynamic frequency assignment, you can vary the dynamic frequency assignment from the both base stations. Okay, these are the main thing in the frequency assignment and also dynamic frequency assignment. Okay, coming to co-channel interference and also adjacent channel interference. Okay, what is interference? That some noise will be occur. Okay, that signals from cells that share a co-channel cause co-channel interference. Whenever signals from the cells that is share a channel, Okay, that's area channel. For example, here what is a co-channel? Okay, what is the adjacent channel? Okay, here this is the co-channel. Whenever we place the another base station in the particular one cell, okay, here in the place we are placing the two base station. In the place we placing the one base station. Okay, whenever a noise occur from the particular cell in the particular cell, that is called co-channel interference. That is called co-channel interference. Whenever noise will be occur from the adjacent cell, the neighboring cell, that is called adjacent channel interference. Okay, this is the interference between the co-channel and also adjacent channel interference. Okay, next we can see the cluster. Okay, and right now we just discuss about the cluster. What is a cluster? That is a group of cells called cluster. You can observe here. Okay, in this cluster, this is a 3-cell cluster. This is a 7-cell cluster. Okay, actually this is a one geograph area. This one is the one geograph area. For example, in our Hyderabad, we divide into the geograph area. In Hyderabad, we are having these cluster. Okay, the cluster having the 3 types of cluster and 7-cell cluster. In the geograph area divided into different clusters. Okay, 3 and also 7. Here we can see the clear picture. Every cluster, every cell having the different radio channel frequency. In every cluster, in every cell also having the different radio frequency. Coming to here also we can see. In the next slide also you can clearly observe. Here reuse factor is 4. Here reuse factor is 7. Okay. Here you can see the yellow one. This color is having the 4 cluster. The cluster size is 4. In this one you can observe the cluster size is 7. Okay. Whenever we go with the cells, that is group of cells are called cluster. This is divided into one geograph area into 3 or 4 types of cell cluster. Here this is 7 type of cell cluster. Okay. You can observe differently colors. Then we can find out the reuse factor of the particular cluster, and also we can see the what is the reuse ratio also, that we'll see in the further slides. Okay, you can see the standard model using the 7 frequency. The cluster size is 7. N equal to 7. The cluster size equal to 7. What is done by certain distance between the base station? This F4 base station and also F5 base station. Okay, this in between certain distance, that is called cluster size. Then we can see the 7-cell cluster that is having the different colors, the frequency radio channel. Okay. Coming to here, you can see the frequency 1, frequency 2, frequency 3, the different colors. And also you can see, for example, this is a cluster size 7. This is a 7 cluster size. We are having the different frequency spectrum. In the frequency reuse pattern, we are having the different spectrum. You can observe the first one having the 100 MHz, the second one having the 200 MHz, and also 300 MHz. 400 MHz, 500 MHz, 600 MHz, and also 700 MHz. Different colors and different cells having that the particular frequency spectrum. Okay, you can observe every color having a different frequency spectrum. This is a cell cluster in the frequency reuse pattern. You can observe in the clear. You can observe here what is the channel interference. Co-channel interference are also called. Also, we're having the adjacent channel interference. Okay, whenever interference will be occur, here you can observe. Here you can observe from the these are the one base station, another base station. These are the base station. Every cell having the one base station. Every cell having the base station. Whenever interference occur with the these base station to this base station, okay, then that is called adjacent channel interference. Okay, this one is adjacent channel interference. Okay, you can observe here interference between the boundary. It is interference with the boundary. This is also called adjacent channel interference. These are many types of adjacent channel interference. You can observe here also same thing. Okay. The next, what are the available channels in the particular cluster? For example, this is a cluster. What are the what we having the how many available channels? That is represented with the S. Okay, and also adjacent cells called cluster. That is available channel S, and also the cluster size M represented with the M. The finally we get the each cell gets K channel. Okay, actually S equal to K into N. We know that N is a cluster size. Cluster size. N is the cluster size. S is the available channels, and K is the each cell gets K channel. Okay, this one is the frequency reuse factor finding purpose we are taking. We can see the some example also. Okay, in the reuse factor we having the some limited capacity, the first mobile radio telephone service when related to the spectrum used. Okay, that not much sharing the a lot of bandwidth dedicated in a single call. That with the help of this one, we can go with the good coverage. Whenever we using the frequency reuse concept, we can give the good coverage. But sometimes, with the frequency reuse, we have the interference. For that overcome, we have the another method that we'll see in the further classes. But whenever we use the frequency reuse concept, we can give the good coverage area to the particular subscribers. But interference also will be there. That is impossible to reuse the same frequency. Okay, then we can see the another methods for the overcome the interference in between the two cells. Okay, coming to silent features of the using frequency reuse concept. Okay, you can observe here. This one also cluster. How we can find out the frequency reuse factor? This is a 1 by n. The frequency reuse factor 1 by n. Okay, the total number of channels equal to s equal to k into n. Then the cell with the each same letter. Okay, where here we are having the a, and here we are having the a, here we are having the a. The same set of group of cell having the same frequency frequency spectrum. Okay, here we are having the same spectrum. Here also here having the same frequency spectrum. Here also same spectrum. We can find out the number of channels allocated for that cell. That purpose we go with the this total number of available channels. That is s. Okay. You can see here in the with the reuse ratio. Okay, then formula is the reuse ratio equal to q, the frequency reuse factor. The formula is a d by r equal to q equal to root 3, and we can also write root 3 n. Okay, the n is the cluster size. The d is the distance between the center of cells. The distance between the center of cells, and also radius of the cell r is the q is the reuse ratio. We have the two formulas, q equal to d by r, and also we can write d by r equal to root 3n, and also we can write q equal to root 3n. Okay, with the help of these factor we can find out the reuse ratio, that is a q. Or we can see the example. Okay, they given in the question n equal to 7, and also radius is a 5 kilometer. We know the formula q equal to d by r, otherwise root 3n. Then from that we can, what is that, d equal to root 3n into r. Then we substitute the n value here. What is n value? N equal to 7. Okay, then we get the 22.91. Okay, the minimum distance between the same frequency can be approximately 4.6 times, that which is in the coverage area is the 22.9 kilometer. Okay, 22.91 kilometer. Like this we can find out the frequency use concept. Okay, and also next one is the channel assignment strategies. Just now we discussed what are the channel assignment strategies. One is a fixed one, and second is a dynamic one. Okay, for that we are having the one comparison table. You can see here. So first key point is channel allocation and blockage, frequency reuse, frequency uses, tangible, and also algorithm, cost, cell allocation, and MSC. Okay, when go difference of the fixed channel allocation and also dynamic channel allocation. First of all, what is the key point? Channel allocation. In the name itself, here we can go with the fixed number of channels or wide channels are allocated. Okay, that means we can go with the only fixed number of channels in the particular channel allocation strategy. But coming to here, those are not fixed initially. But if, for example, in the fixed FCA, we are giving the 10 channels. If we in the DCA, we are not committed with the fixed channels. Okay, that can vary. If we needed 13 means, 14 means, we can add it. Okay, coming to blockage. If channels are occupied, then user call is blocked. For example, here we having the 1 to 10 channels in the FCA. Okay, all the 10 users are occupied. All the 10 users are occupied means for the next customer, what will happen? Here the call cannot be connected. Indication will come. Call cannot connected. Okay, like that the indication will come. Okay, in the fixed channel strategy. But coming to here, dynamic channel allocation, if all the channels are blocked, okay, if all the channels blocked means in the fixed FCA, what will happen? there is no call conversation between the one user to another user. But here we have the flexibility. We have the flexibility in the DCA. Okay, if all channels are also blocked, the base station requests the more channels from the mobile station center, that is a MSC. We can also call mobile switching center, that is a MSC. Okay, there we give the request. Here all channels are occupied. We need the channels. That purpose we are giving the request to the MSC. They allocated the channels to the fixed channel assignment strategy. Clear? Okay, don't confuse. This one is a clear. What is the fixed channel assignment strategy? What is the dynamic channel assignment strategy? Okay, if you go for the fixed channel assignment strategy, what will happen? If all the channels are occupied, there is no conversation. Okay, there is no chance. The indication what will come? Network error, or otherwise call cannot be completed. Okay, there is a indication will come to our mobile phone. Okay, if that we're coming to dynamic channel assignment strategy, if all the channels are occupied, all the persons are blocked. Also, we are taking the some channels from we given the request, the particular base station, the nearby base station requests the more channels to the MSC. Okay, then they will allocate some channels to the particular base station. Then the call is connected, the connection is established. Okay, this is a blockage in between the fixed channel assignment strategy and also dynamic channel assignment strategy. Coming to frequency uses. Okay, see here what is the frequency usage in the fixed channel assignment and also dynamic channel assignment. Here you can see it is the frequency use is very high, being the call channels are separated using minimum use distance, because those are fixed. We are unable to change the channels, but those are fixed means they're having the high frequency. But coming to here, the frequency use not the maximum, because random channel allocations. Because random channel allocations, if we need means we can take request. But here there is no chance to take the channels from the mobile switching center. Okay, that is a tangible means. Here we can go with the hardware can be touched being the physical electronic device. But coming to here, the software being digital can be seen, cannot be touched. Okay, there is a hardware in that, here in that software. Next, algorithm. Coming to algorithm, no need to complex algorithm, because all are fixed. Why we go for the complex algorithm? Because already everything is there. There is no need to go for the complex algorithm. But coming to here, algorithm determine efficient channel availability. Quite complex in the dynamic channel allocation. Okay, here we go with some big dynamic channel allocation. Coming to cost, FC is a cheaper than DCA. Why it is a cheaper? Means all are fixed, but there is no connectivity to the another MSC. But here we have the connectivity. This one is some real-time computation needed. That's why this is a cost. Why that is a real-time computation is needed? If we need, we can request more from the mobile station. Then the cost will be high. But here there is no need of anything. Whenever the setup is or installation is over, then that's the cost only. But here every time will be changed, the real time. Okay. For example, the more subscribers are there, then we can go with the channels from the MSC, and also we can return back. Okay. After that, if needed, and one more time, we can take the channels from the MSC. Okay. Coming to cell allocation. Once call is complete, channel remains with the cell. Okay, for example, here 1, 2, 3, 4 channels are there. Okay, whenever it is free, only one person connected to the user will connect it to the any of the particular cell. Okay, coming to here, 1, 2, 3, 4 are occupied. Then we can go with the fifth channel from the MSC. We are taking from the MSC. Okay, we are taking the MSC. And also, whenever this call is completed, okay, fifth call is completed, then we can return back to the particular MSC. Okay, if it is we needed, we can take from the MSC after call is completed. Once call is completed, channel is return back to the mobile station center. This is in the cell allocation. Coming to mobile switching center functionality in the both fixed channel allocation and also dynamic channel allocation. What is that? Mobile station center has less burden. Why it is having less burden? Because no need to give the channels to the particular fixed channel allocation strategy. Okay, but here we in this dynamic channel allocation, we providing the channels. We are providing the channels. That's why the center high has load and also more responsibility. Okay, in the real time it is using the mobile station center allocation. Okay, these are the major difference in the fixed channel allocation and also dynamic channel allocation. Clear? Mainly we can where is the main difference in between? Here the fixed channel allocation, here we can take the random channel allocation. Okay, we here once call is completed, the channel remains with the cell. Okay, then we can connect with the another person establishment. But coming to here, once call is completed, we can back to the MAC. Okay, that is a major difference in the fixed channel allocation and also dynamic channel allocation. Coming to handoff procedure. Coming to handoff procedure. Okay, in the previous class also we seen one graphical representation. What is a handoff? The handoff is nothing but handover. Handoff is nothing but handover. Here you can see the cellular communication in a handoff process, transferring an active call to a data session from one cell in a cellular network or from one channel to another. For example, here we can see this is a one base station, this is a another base station. Okay, this is a base station, this is a B base station. Now, for example, two different areas in a one town. Okay, whenever you traveling from the A to B, whenever you traveling from the A to B, whenever you reaches the boundary, the signal, actually this one is a signal in the A cell. Whenever you reaches the boundary, automatically the signal will decrease. Okay, come in the difference in the channel boundary of the particular cell coverage area. Okay, then that purpose we are go with the handover technology, or also called handoff technology. That is a process of transferring an active call. Okay, whenever the person is moving on to the or while traveling from the A to B, okay, A to B, we can give the active call or data session, or they are using the internet, we can give the data session. If it is a call using, then we can go with the active call from one cell in a network or from another channel to another. We can take the we can hand over the signal to A to B. Okay, but in the without handoff process, the signal will drop. Whenever it reaches the boundary, the signal will drop. In the real time also you observe. Okay, when you are traveling from the any hill station or forest, the signal automatically drop. For example, 5 points is there. If it never reaches to the boundary, the signal will drop to 1 or 2 points. But coming to handover technology, there is no call dropping and also signal dropping. Okay, we can maintain the same signal from particular one cell to another cell. Okay, from area A to area B, we can go with the same signal, same call connectivity. Okay, there is no any distortion disturbance in the handoff procedure. This is in the handoff procedure. It is a necessary preventing the loss of interruption. What is interruption? Without a handoff procedure, what will happen? The signal will drop and also call will disconnect. Sometimes the call also will disconnect. Okay, when we go with the handoff procedure, we are preventing the loss of interruption service to a caller or data session to user. This is also called handover. Okay, that purpose we are go with this handoff procedure, and also we can see what are the different types of handoff procedure. Okay, coming to here, this is a 4 base stations in a one particular cluster. Okay, cluster is nothing but cell. Okay, cluster is nothing but cell. Here we having the 4 different cells in a particular cluster. Here, this is a boundary. This one is a boundary. This one is a boundary. Okay, whenever you travel from this base station of cell 3, you are traveling from here to here. Okay, without handoff procedure, what will happen? The signal will drop. Okay, with the help of the handover technology, the total signal remains to the from base station 3 to base station 4. There is no any interruption in between the both the coverage area. This within the handoff procedure. Without handoff procedure, the cell will drop. Okay, and also we having the 2 different types of handoff procedure. Two different types of handoff. One is a soft handoff, and second one is a hard handoff. Okay, both those are the 2 different handoff methods that will also we can see here. Okay, these are the two different types of methods in the handoff process. Actually, what is a handoff? Whenever having the active call from the one base station to same thing, we can hand over to the another base station. The active call or active data session. Okay, here we can see the situations for the triggering handoff. One is a subscriber who is in a call or data session move out from coverage area one cells to one center coverage area another cell. Then handoff is triggered from continuous of service. There is a continuous of service, and also we can give the each cell is has a predefined capacity, and also it can handle only a specific number of subscribers. Okay, if more subscriber is there, we can go with the same cell another radio channel. Okay, in here we can use another cell. We can place another cell. Every cell act as a one base station. Every cell having now their own base station with the same radio frequency. For example, with the help of frequency reuse concept. With the frequency reuse concept, we can improve the capacity of the coverage area. We can improve the capacity of coverage area. Improve of capacity of coverage area. Okay, that is a main advantage of the frequency reuse concept. Then we can go with the this one. But coming to handoff, then we have the two types of handoff processor. One is a soft handoff and another one is a hard handoff. Okay, that is cells are often subdivided into micro cells. That will also be seen in the last class. Okay, these are the two different types of handoff, soft handoff. Okay, what is a handoff? Okay, in a handoff, actual break. Okay, actual break in the connection occurs while switching from one cells to another. Okay, this policy is called break before make policy. This policy is called break before make policy. Okay, this is a handoff. You can see the representation of the what is a soft handoff, what is a handoff. Then you can understand easily. Okay, okay, this one is a make before break policy. This one is a make before break policy. You can observe clear break before make. That means if here we are having the two cells, here we are having the two cells. Whenever traveling from this base station to this base station, break before make. Before this is a break in between the two cells. Then only before that only take the connection from the this service area signal. Before only it will take. Okay, that is a break before make policy. Coming to here, this is a soft handoff. This is a make before break. Okay, this is a break before make policy. This is a make before break policy. You can observe here. Okay, the connection is after breaking only connection is established. But here there is no break. Before break only the connection is established. This is a handoff. That one is a soft handoff. Okay, clear? In this one mainly we go with the two different types of handoff processor. In the next class you can see clearly what is a queuing method, what is a umbrella approach, and also what is a prioritizing handoff. That one also improving the cell coverage area. Those are the important topics in the particular handoff processor that will also we can see in the next session. Okay, this is a hard handoff and this one is a soft handoff. Okay, here we taken the reference from these textbook. You can go through textbook, then you can understand easily whenever having the doubts in the mobile cellular telecommunication. You can take this reference. Okay, in the next class we can go with the handoff procedure and also trunking and get off service. Okay, that is a very important for the cellular mobile communication. That will also we can see in the next session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.